Hi, my name is Kyle Mastracci, and this is our DP3 presentation for our product called the Equalizer. So a little bit of review from DP1, we have our mission statement which outlines what our product is. So it's essentially a temperature controlled outlet to be able to plug in a fan or a heater, and it's targeted towards college students who live in a dorm without AC, or if it's very cold in the winter you can plug in an extra heater, and it's controlled based on the temperature of the room. So a couple of our customer needs that we identified through our customer surveys were that the temperature at which a fan or a heater toggles on and off needed to be adjustable. Our product needed to be low cost because there are competitors out there that perform essentially the same function. And then also the outlet needed to be universal, so you could use this product anywhere with any fan. So the specifications that we got out of those customer needs were that it needed to have a standard outlet output. So essentially it needed an outlet that is common to North America that most fans and heaters would be able to plug into. And also that you needed to be able to, it needed to have variable temperature control. So you could change the temperature based on the season or even the day. So from DP2, we had our concept generation and selection. So to start with our concept generation, we did the 3-2-1 method in class where we pass around papers to each team member, and they drew their designs for the product and pass them along to other teammates to give feedback. And we brought these designs into class to perform the gallery method, which is where our peers walked around and they gave us feedback on our product while we gave them feedback on their product. And combining all of this feedback that we got, we eventually determined the specifications for our product were going to be that it needed to be outlet powered, it needed to have 2 outlets to plug into, and it needed to be, the temperature needed to be controlled by manually coding in the Arduino software. Researching patents was also another great way that our team was able to generate ideas for how to come up with specifications for our product. So a couple that already exist are that there's a temperature sensor that stays on the outside of the housing. This is for the temperature sensor to be able to actually gauge the temperature in the room, because if you had the temperature sensor inside with the Arduino, inside the housing, it could possibly be affected by any of the Arduino components that heat up even in the slightest. So the other specification that we came up with, as I just mentioned, was that the microcontroller or the Arduino will be set inside the housing. And this is mainly for aesthetic purposes, and it makes it look better, which makes it more marketable, and you'll hopefully be able to sell more of your products. And the other is that it will have some sort of indicator to tell you whether or not the product should be working or not, whether or not the fan plugged into the outlet should be on. And what we decided for this was that we were going to have a servo motor that, if the fan is on, the motor is spinning. And we had that outside of the housing so that it's clear for the user to see. So we also performed a failure modes and effects analysis on our product. So basically what we wanted to do is we wanted to figure out ways that our product would break. So the ones that we essentially came up with were the indicator servo motor that I was just talking about. That could be damaged in some way, whether it's dropped or it has too much power supplied to it and it burns out. But because that is not part of the main function of the product, we deemed it to not be too important to the overall operation of the product. Some of the other ones though were the output outlet. If the outlet itself that is connected to the Arduino is not working, then the power coming from the wall outlet will not transfer to the fan or heater, and therefore your product will be doing nothing. And so we deemed that as very critical to the operation, and we had to come up with ways to make sure that that did not break. And so basically what we figured out was if we just have to make sure that we do proper soldering and having the outlet securely connected to all of the Arduino parts. Another one was the wall outlet plug. It's essentially the same function as the outlet as before, but this one is coming directly from the wall, so you don't want that to you need like surge protection or something on that so that it doesn't damage your product or the outlet in the wall. And the other is the temperature sensor, which is probably the most integral part of the entire product. You don't want the temperature sensor to be damaged because then your product, it will not read the correct temperatures and your product will not function like it's supposed to. So we had our design for assembly exercise, which is essentially how quickly you can assemble one unit of your product. And so we determined with our product that you're able to create one in around 421 seconds. And this is relatively low, which means that your added cost for each unit is only going to be $1.75. And this is very important for a product like ours because you want to be making as many as possible. And if you are mass producing the product, you want the price to be as low as possible as well. And so having that low amount of cost for each unit to be made in a shorter amount of time is much more beneficial. So now we have our bill of materials, which basically outlines everything you need to create our product. So in our bill of materials, it lists many things that you would not need to create multiple of the products. So for example, we have down towards the bottom, we have wood glue and sandpaper. Neither of those are going to be products that you're going to have to buy more than once if you're mass producing this product. So our total cost right now is $49.61, but this cost would be greatly reduced if you were mass producing the product. So these are our CAD models for our product. As you can see, it's two separate pieces. You have the bottom part of where the Arduino sits and the top portion where the outlet slips into and closes it for aesthetic purposes. So as you can see in the back here, there are two holes in the back. This is for the power to be plugged into the Arduino and to be plugged into your computer so that you can change the desired temperature as well as reading the temperatures that the temperature sensor is currently reading. And then on the top, you can see a wide area for the outlet to be put into and a smaller area here for the temperature sensor to be outside of the housing so that it can accurately read the temperature of the room. And these two are connected with small screws that go right here in these holes on the top. And here are a few multi-views of this part. So as you can see here again, you have these two holes where you have the extension cord that plugs into the wall outlet has to come into the housing to be able to connect to the outlet underneath, as well as the relay which controls the signal from the Arduino to the outlet. And then on the top here you can see the large hole for the outlet, and the outlet will sit inside the hole. It has small screw holes to be held in place, but for our actual final prototype, the hole was small enough to where the outlet fit tightly and did not need to be screwed in. So as you can see, here's our final product. It shows the combination of all our design changes that occurred through the duration of the design. And you can see the outside of the box, it's securely closed. We wanted to go for the most aesthetically pleasing we could, and so all these wires that you see on this side are all hidden on the inside of the housing over here. This small black piece of tape right here is connected to the servo motor that's on the outside that indicates whether or not your product is supposed to be on or not. And here you can see, this is the setup of the Arduino. You have all the wires coming through this relay. This relay tells the outlet whether or not it should be supplying power to whatever you have plugged into it. And finally, the improvements that we could have made to our product. The temperature sensors that we bought for our specific product, as college students, we were trying to save as much money as we could. So we bought these temperatures over here. They're TMP36 temperature sensors, What they do is output a voltage based on the temperature of the actual sensor, not the temperature in the room. This temperature sensor here, as you can see, has small holes in it, and that will better accurately reflect what the temperature in the room was. Other improvements that we could have made was using a microcontroller that was not quite as beefy as the Arduino was, because the Arduino took up a lot of space in our housing, and if we could use a microcontroller that did not need quite as much room to sit, then we could greatly reduce the size of our product and make it even more aesthetically pleasing and more convenient for college students who might need it sitting on their desk